All right, so problem number 2, right over here. Which figure in the diagram is a rotation of figure number 5? So figure number 5, I'm going to trace over this. This is where tracing paper might come in really handy when you're on the test. Even though I know we're not talking about symmetry here, I'm going to trace over my orange. The leaf is over here on the left side of the stem. If I'm doing a rotation, I should be able to spin this, and it should match up perfectly with one of my other oranges. Do you guys see another orange that would match up perfectly anywhere on this spin? 2. There we go. So figure 2 is a rotation of figure 5. In this case, it happens to be a 180-degree rotation because we flipped it all the way upside down. A translation, I'm going to trace over my orange again. Here's my stem, and the leaf is on the left-hand side. Translation is a slide, so I'm not allowed to twist it. I'm not allowed to flip it. I'm allowed to take it down. I'm allowed to take it left and right. I'm allowed to take it diagonally. Do you guys see one of these oranges that looks exactly like this one? Figure 4. Translations are the only ones that preserve our orientation, which in that case means if the leaf is on the left side of the stem, in my translation, the leaf still needs to be on the left side of the stem. All right, then we come to a reflection. Which one of these looks like a reflection of figure 5? 1. I've had people from 1st through 5th period asking me, well, wouldn't figure 3 work? And the answer is no, not for just a reflection. Figure 3 is a reflection and a translation. It didn't just get folded. A reflection is just a fold. There's no line up here that I could fold figure 5 over and get figure 3. I just can't make it go there with a single fold. If I fold it and then slide it, so a reflection and a translation, then I could do figure 3. What else do you guys want to see? 7. And which one? 9. So 7 and 9. Let's go to 7 first. All right, we're going to graph segment AB. A is -1, 8, right up here. And B is -5, 6, right here. I'm going to grab my straight edge and I'm going to connect those two together. First thing they want me to do after I graph that is a translation, and then they give me this vector right here. It's kind of hard to see, but I want you guys to look carefully. Very bottom one is another copy of the test review. These are not parentheses around the -4 and the 2. These are angle brackets. There is a little bit of a point to them. When you see those angled brackets, not smooth, soft, curved parentheses, angle brackets means we are translating, we are moving, we're going to slide or shift. My translations can go up, down, left, right, or any combination of those. Which one does it always tell me about first, this -4? Left and right, because that's where the X is, and my X-axis goes left and right. In this case, would we be going left or would we be going right? Left. Left 4. And up 2. The second number always tells me about the up and down. So first it's the X and then it's the Y. How am I moving in the X direction? How am I moving in the Y direction? You can do this one of 2 ways. You can come over here and you can count left, 1, 2, 3, 4, and up, 1, 2, and plot your point. Or you can come to the ordered pairs. To go left 4, you would -4 from the X's. To go up 2, you're going to plus 2 to the y's. And I can use that to get my a prime and b prime. What is negative 1 minus 4? Negative 5. What is 8 plus 2? 10. So a prime should be at negative 5, 10. Is that where I plotted it when I just counted it over and up? Did I put it at negative 5, 10? Yep. So I can get a prime either by counting or by doing the subtracting and adding. Either way is perfectly fine. Where should point b prime be? Negative 9 and 8. So negative 9, 8 would be right here. Here's my b prime. I'm going to connect those two together. Last thing they're asking me to do on this problem, we're going to reflect across the x-axis. What are the rules for reflecting over x? X stays the same. And y? Yes, y is going to change signs. So where would a double prime be then? Absolutely correct. Negative 5, negative 10. So right down here is a double prime. What about b double prime? Negative 9, negative 8. Very nice work. Right here is b prime, double prime. Grab my straight edge and connect those together. A couple things I want to point out before we go look at number 9. If you are not labeling the points on the graph, that will count off. We've got so many points all over the place. If you don't label them, I don't know that you know which one is which. You have to show me that you know that by labeling them. Phones away, please. The other thing that I want to point out or talk to you about, if you want to use tracing paper, even on problems like this, you absolutely may do so. Tracing paper can help if you are scooting it over, or especially if you're reflecting or rotating. It can be really, really helpful. We'll look at other problems as we go through where tracing paper would come in really handy. You guys have access to as much tracing paper tomorrow as you'd like for any of these problems. Number 9, this guy right here. Does the heart have any line symmetry? One line right through the center. I don't know about you guys, but this is how I was taught to cut out a heart out of construction paper when I was in elementary school. They told me to fold my paper, and then I would draw that half heart shape, and then I would cut that out. Is there anywhere else at all that I could draw a line and it would be half the heart? Nope. So yes, we have line symmetry. It's just one line. Does this heart have any rotational symmetry? No. The only way it lines up with itself when I'm twisting my tracing paper around is if I go all the way around to where I started. And if I have to go all the way around for it to match up again, we say it has no rotational symmetry. So what would I put for order and magnitude? Nothing. Leave it blank. I had somebody ask me earlier, can I put, or should I put zeros there? Just leave it totally blank. Don't put anything there. What about the 4-leaf clover? Do we have any line symmetry there? 4. Tell me where to draw those 4 lines. Vertically. Diagonally. And horizontally. So we have 4 line symmetry. Do we have rotational symmetry with this? Yes. With what as the order? 4. If I start with this leaf right here, we can come 1, 2, 3, back to the beginning. And so my magnitude would be what? 90 degrees. 360 degrees divided by my order, which is 4. And that gets me my magnitude. Oh, lovely. I've been having so much trouble with my board today. I just hope it behaves for the rest of the class period. What other problems do you guys want to go over? Yes. Number 8, absolutely. All right, so the first thing they want me to do is graph this segment. So we're going to graph segment GH. G is 3, 2. And H is 4, negative 5. Grab my straight edge and trace in between those. Oops. There we go. What next? Rotation of 180 degrees. So this one gets a little bit confusing because are my points G and H both in the same quadrant? No. This is another one where tracing paper could come in really handy if you're having trouble figuring out what quadrants it's moving into. What I would do with my tracing paper, I'd lay it on top of my graph. I would trace over the X and the Y axis, and then I would trace over my segment. And then I can twist it 180 degrees. Point G is right here in the first quadrant. If I twist that 180 degrees, it's going to move into what quadrant? Negative, negative, third quadrant right down here. Do I change the order of my numbers? No. So this would be negative 3, negative 2. So here's my point, G prime. H is right over here. He's in the fourth quadrant to start with. When I twist him 180 degrees, it's going to end up where? It's going to come up here to the second quadrant. So there's a 180 degree rotation for H. Here's a 180 degree rotation for G. Tell me about my X's and my Y's up in the second quadrant. X is negative, Y is positive. The order of my numbers stays the same. So this would be what? Negative 4, positive 5. So right here for H prime. Grab my straight edge and connect my points together. Last thing they're asking me to do. Reflect. Reflect over what? Over X equals negative 6. What kind of a line is X equals negative 6? Vertical. If you get to the test and your heart's beating fast, your stomach's all upset because you're anxious and you're nervous and you don't remember whether this is a vertical or horizontal line, and that just makes you more anxious. It has to touch the axis that we have the letter for. It has to touch the x-axis because x is part of that equation. So I'm going to go to the x-axis and I'm going to find negative 6. Does it have a y in the equation? Then it's not allowed to touch the y-axis. It has to touch the x-axis, and it is not allowed to touch the y-axis. So here's the vertical line that we're going to be reflecting across. There's my x equals negative 6. Do we have rules for this kind of reflection? So how do I find my points then? Count. How far away is G prime from that line that we're reflecting over? 3. 1, 2, 3. So on the other side, I go 1, 2, 3. I plot my point right there. That's G double prime. Where did that end up landing? Negative 9, negative 2. How far away is H prime from that line that we're reflecting across? 2. So 1, 2 to get to the line. 1, 2 on the other side. So right here is H double prime. Where did that one end up landing? Negative 8, 5. Grab my straight edge, connect my points together, and I have finished this problem. What else do you guys want to see? Yes. 10, absolutely. So there were a lot of questions yesterday on the stations review for the one that was similar to this. I want to show you 2 different ways that you can go about answering this question. You use the method that you like the best. You don't have to do it both ways. Pick the one that you like the most. The first way, I don't have to show any work. I'm just going to count on my graph. The first number in my vector notation is going to tell me about any left or right shifting that my shape is going through. If I see that it has shifted to the left, will this be a positive or a negative number? Negative. What about if we ended up shifting to the right? Then it's a positive. I need to pick out 2 points that go together. So M and M prime, N and N prime, or L and L prime. They need to go together. It doesn't matter which ones you pick. It should be the same rule for all of them. You guys okay if I go with M and M prime? Okay. I always start at the one that doesn't have the little prime. That's my beginning one. And I'm going to move towards the one that does have the prime. So I'm starting right over here. To get from M to M prime, would I go left or right? I'm going to go left. How far left? 5. We're going to go 5 units left. So what number would I use to represent that? Negative 5. The second number in my translation vector tells me whether we have moved down or up. Negative for down, positive for up. Only slightly ahead of me. You said negative 2. Why? Because we're going down 2 units. So I would use negative 2 for the y part of my translation vector. If you don't like the idea of just counting on the graph, you're afraid you're going to mess up, you want something that's more mathy, we can do this with ordered pairs. I need the ordered pair for the one that doesn't have a prime first. So let's go with M. What's the ordered pair for M? 3, 4. Then I'm going to leave some space, because that's where my translation vector is going to go. I'm going to put an equal sign. And down here is M prime. What's our ordered pair for M prime? Negative 2, 2. Then we're going to look at each of these pieces. I'm starting with a 3. I'm going to do something to it, and I end up with negative 2. What would you do to a 3 if you want to end up with a negative 2? Subtract by 5, and I can double check that on my calculator. What would I do to a 4 if I wanted to end up with a positive 2? Subtract by 2. 4 minus 2 would give me 2. I got the exact same translation vector, whether I did it by counting or whether I did it with ordered pairs. You pick the way that you like the best. What else would you guys like to see? 12 sounds good. If you do not know your rules for reflection, because I'm not giving you the rules for reflection or for rotation tomorrow. If you don't know your rules for rotation and reflection, I would highly recommend making some flashcards tonight and working with those. If you don't know those rules, you're really going to struggle on the test tomorrow. I'll still happily make tracing paper available. If you know how to use that tool, that will help, but you really need to know your rules. Speaking of knowing rules, what is the rule that we have for y equals negative x? We're going to switch. And we're going to change both signs. So I'm going to switch the order of the x and the y. And we're going to change both signs. So I'm going to come up here and look at my ordered pairs. I'm going to change everybody's signs. So these guys become positive, then a positive, negative, and then a negative, negative. I changed everybody's signs, and now I still have to switch them around. So what would S prime be? 2, 3. T prime? Negative 3, 2. And U prime is the easy one. Negative 2, negative 2. Since we're back here on the back page and we've done 10 and 12, do you guys want to do 11 or do you want to skip that one? Okay, let's do 11. I'm only looking for a single word on each of these lines. I just want you to put the word translation, rotation, or reflection. That's all I want. If it is a translation, it's a slide or a shift. This is where tracing paper would really, really, really come in handy again. If I'm checking for a translation, I'm going to trace over my original shape. And I'm going to try to slide it around on my page to make it match the other one. So is there anywhere that I could slide this and make it match up with that other shape? So it can't be a translation. A rotation would be a twisting. Is there any way that I could twist this to make it match up with the other one? Let's find out. If I come over here, I'm going to keep twisting it. Ah, come back. Yeah, I can't make it work with that. So if it's not a translation and it's not a rotation, it must be a reflection. I'm not asking you to tell me what we're reflecting over, but if you want to get fancy, that's what we would be reflecting over right there. Notice D and D prime are both 1 unit away from that line. C and C prime are both 3 units away from that line. It's a mirror image on either side of that. All right, let's come over to the middle one. I'm going to use my tracing paper. I'm going to trace over this shape here. And I'm going to try to slide it to make it match the other one. Will I be able to make it match if I slide? Yes, which means this is what? This is a translation. And then we have this last one back here. It's got to be a rotation because I've used all my other letters, right? A is down here, B is up here, and C is right here. If I twist this, I can make B land on top of B prime. I can make C land on top of C prime, and A land on top of A prime. I'm not rotating about the origin on this one, but I am rotating because I could twist my paper and make it match up. So this is a rotation. We have 8 minutes left, which is about enough time to do 2 or 3 more questions, depending on how long they take. Yes? Number 3. That one's going to take us a minute. Let's go look at that one. This is a really good one. If you don't know your rules, you won't be able to do a question like this on the test. You have to know your rules. What is my rule for reflecting across y equals x? We're going to switch the x and the y. Here's the best little trick I've come up with to be able to remember this one. When we reflect over x, x stays the same, right? When we reflect over y, y stays the same. When I have y equals x, normally in my ordered pair, which one comes first, the x or the y? Normally it's x comes first and then y in my ordered pairs. When I look at this equation, which one's coming first? The y. That helps me remember to switch it around. So E prime would be 24, negative 5. Reflecting across the x-axis, we just said the rule for that is what? X stays the same, and y is going to change signs. So E prime would be negative 5, negative 24. Rotations. Clockwise, 270 degrees. I'm going to get a quick sketch going on so that I know where I'm starting from. Negative 5 would be over here. Positive 24 is going to be up here somewhere. So E is in the second quadrant. We're going to go 270 degrees clockwise. That's going to put me into what quadrant? Into my negative quadrant. Do I do any switching? Yes. We're going to switch and match signs. So E prime, if I just switch the numbers around, it's 24 and negative 5, but we're going into the third quadrant. So what do I need to do? They need to both be negative, so negative 24 and negative 5. What about counterclockwise 270 degrees? Let's go look at that one again. Quick sketch. I know E is here. Counterclockwise 270 degrees is going to put me into what quadrant? Into the first quadrant. Here's 270 degrees, so we're going to go into the positive, positive. Do I need to switch? Yes. Switch and match signs. So E prime would be what? 24, 5. Nice work. The next one is the same as C. Absolutely correct. Counterclockwise 90 degrees is the same as 270 degrees clockwise. So this way. Wait, did I do that? Hold on a second. What am I doing? Counterclockwise. Yeah. Okay, sorry. I'm reading things wrong and now I'm getting all kinds of confused. So E prime, negative 24, negative 5. What about 180 about the origin? Yeah, here's E. We're going to go into our positive, negative quadrant. Doesn't matter which way I go. Do I switch the order? No switch. Match signs. So E prime would be what? 5, negative 24. Before we do part G, I want you guys to look at all the ones that we've done so far. Every single ordered pair that we've answered, A through F, have the same two numbers. They both have a 5 and a 24 in all of them. When I'm rotating about the origin, when I'm reflecting over X, reflecting over Y, reflecting over Y equals X, reflecting over Y equals negative X, same two numbers. Sometimes they're flipped around, sometimes they're positive, sometimes they're negative. This last one is the only one that we're looking at on this problem where we're going to end up with profoundly different numbers. It says we need to add 11 to the x's. It's going to send it right 11. And subtract 9 from the y's. That's going to send it down 9. So where would my point E prime be? Six. And what's 24 minus 9? 15. 6, 15. The only other way that I end up with ordered pairs that aren't the same two numbers that I started off with, just switched around or negative, positive, is if I'm reflecting over something like y equals a number or x equals a number. That's the only way I end up with digits that are different than what I started with. Answer key is already posted in Canvas. The way you get there, because every module has somebody tell me that I didn't post it, you have to get into modules, find today's date. You have to click on the page. It won't just be right there in the module. You have to click on today's page and scroll all the way down to the bottom. Please turn in your warm-up before you leave. You'll be turning in your reviews tomorrow before your tests, so please finish those up. Let me know if you still have any questions, and good luck on the test tomorrow.